Welcome back, my fellow Python programmers, to a brand new video, and in this one we're going to be working on list manipulations as a Python exercise. And we're going to be covering the following topics. So, if at any point you feel that you're enjoying the contents of this video, please make sure to slap that like button because I need to beat the YouTube algorithm. Let's go ahead and get started. Okay, so this is the list manipulation program guide. Let's go ahead and get started. First of all, we are going to need to write a program that reads integers from the user and stores them in a list. Pretty simple. Next, you'll need to continue reading values until the user enters 0. So can you guess which loop in here you should be using? Next, you'll need to display all the numbers except 0 from the smallest to the largest. So we're going to need to somehow sort these numbers out. Now display the same numbers but in reversed order. Display the numbers but with the biggest and the smallest numbers removed. This is going to be very important. Remove all the duplicates from the list numbers, and this is going to be a list of methods that you can use in order to do the following stuff. So you'll have sort, sorted, reversed, reverse, set, list slicing, and also set another time because I'm a moron. So this is just a guide. You don't have to use any of these. You can use some of them. You can use half of them, and you can use only one or two from the sort and sorted. I recommend that you go do your research when working with these methods, but the most important part is that you finish the program entirely. So if you want to do this program by yourself, pause the video right now and go do the program. If not, you can watch me, and if at any point you feel that you're doing the program but you're stuck somewhere, you can always watch the part that I did and then pause the video there and then continue on with the program. So I give you full control of everything. So I will see you in 3, 2, 1. Okay, so first what we did is we defined a new function that is called main. Now you don't have to do this, and by the way, you don't have to do exactly the same code as I did as long as your code works without any breaking points. Basically, we created a method in here, or a function that is called main. Now naming a function main is just a convenient way to indicate the starting point of a program. We could have named this anything. Inside the main, we start by creating an empty list that is called the numbers. This list is where we are going to be storing all of our integer values entered by the user, which will allow us to better manipulate the integers that we receive. Because remember, we're going to be sorting them, we're going to be removing stuff from them, so setting them in a list is a good way. Next, we have a while loop with the condition set to true. This means that the loop will continue going on forever until we tell it to stop. And this is perfect in our case because we want to keep asking the user for inputs until they decide to exit out with the 0, and this is the condition where we exit out, but we'll get there. First, we need to talk about this try. Now, you might have not used this try, it's not necessary, but the reason why I used it is because we're going to be attempting something that might fail. For example, if the user enters a string which cannot be converted into an integer. Because remember, when we are getting inputs, these are strings, and then we try to convert them into an integer. Now, if the user enters something like Michael, for example, that is not going to be converted into an integer, and we are going to get a value error. So we put it inside of a try block in order to make sure that these errors get handled gracefully and do not just crash our entire program. So then we ask the user to enter an integer, so we get the input with a prompt which tells the user to enter an integer with 0 to finish, and then once we get it, we convert it into an integer, and then we put it in a variable that's called number. After we've done that, we immediately check if this number was indeed equal to 0, and if it was, we break out. This is going to be our exit condition, allowing the user to stop entering numbers whenever they are ready or whenever they enter 0. Now, if the number isn't 0, which means we don't break out, we then get the numbers list and we append it using the append method by the, or we appended with the number that we got as an input. And finally, we have the except block right here. Now inside the except block, keep in mind we're also inside of the while method. You can see this by the indentations that we have. Inside of the except block, we catch any value error that might have been raised during the attempt to convert the user's input into an integer. Now, so everything that's been done inside of the try block is going to be catched, or if an error is raised, will be catched or caught. It's good. I'm not a English instructor. I'm a Python programming instructor. Will be caught by the except block if it's a value error, and this error occurs if the input is not a valid digit. So right here, I told them that please enter a valid integer or a digit to be converted. So this is our program. Let's just quickly run it, and I'm going to change this later on, but I just want to test it out, make sure that everything works. So 5, 10, 50, and if I try to enter Michael, boom, there we go. Please enter a valid integer. So Michael cannot be converted into an integer because it doesn't make any sense. So we were able to catch it inside of the try except block. Okay, so in here, after we've collected all the integers from the user, we move on to actually sorting out our list. We use Python's built-in sorted function for this, and if I hover over the sorted, I should get the document, so you can see that it returns a new list containing all items from the iterable in ascending order. That's perfect for us because we said we want to print it from the smallest to the biggest. Then we obviously print out this sorted list, and then finally I also wanted to print out each individual number that was entered on a separate line. So now if I right click and I run, let's enter 9, 6, 5, 8, 4, 2, 3, 1, 7 or something like that. And then when I enter 0, you can see that the program actually stops asking me for questions. It gives me the sorted numbers, and as you can see, we also have them sorted right here. So everything works good. Now you might have also used the sort, and that would have been also good, but the only thing in here is that the sort would actually sort the numbers list out. And what I mean by that is that the numbers list is not affected. Let me show you what I mean. So 9, 5, 1, 4, 6, 2, 7, 8, whatever, and then 0. So as you can see, I'm printing out the numbers. It has not been changed after the sorted was used on it. If I use the dot sort, and actually the dot sort doesn't even return anything. So if I try numbers dot sort, you can see that the sorted number is unavailable to us. If I right click and I run, I might get an error in here. So this is just to test things out really quickly. As you can see, this is a none, and we tried to loop through it, and the actual list numbers was sorted. If I hover over the sort, you can see sorts the list in ascending order and returns none. So that is the main difference between using the dot sort and the sorted. Both are good. I just decided to use this sorted in this case. Okay, so first of all, what we did in here, or actually what our entire goal of this part of the code is for us to actually reverse the numbers that we have. So basically what I did, first of all, is I separated these two outputs visually by printing out these dashes 50 times. So this is a string. When I multiply it by an integer, when I multiply it by an integer, it basically will print out 50 dashes. So this will allow me to separate between the sorted list and the reversed list. Next, I created a new list that is called the reversed, or it's not actually a list, you'll see what I mean, but I just set the reversed. I use the reversed. If I hover over it, you can see that returns a reversed iterator. Not a list, a reversed iterator over the values of the given sequence. And then I stored it in the reversed numbers. I printed it out, and then I went through it again. So let's see the difference between an iterator and a list. So if I right click and I run, you can see that in here 9, 6, 5, 8, 7, 1, 2, 3, 0. Boom. So as you can see, the list right here, as you can see it was sorted out, and then it was reversed, and you can see it by the 9, 8, 7, 6, 5, 4, 3, 2, 1. So it was in or reversed. But as you can see, when we try to print it out, you can see that this is a list underscore reversed iterator object. So an iterator is something that or an object in Python that you can iterate over. So we can use it in a for loop, but it's not a list. If we really want to use it as a list, we can do the following. We can convert it using this list constructor. Now, this, as you can see, built-in mutable sequence, it's called a constructor. If I'm not mistaken, yes, it is a constructor because it's using the init. This is something that we already learned in previous chapters. If you want, you can always go back and watch that one. But anyway, this is how we would do it. Right click and run 9548761 0. Boom, there we go. As you can see, now it is in the form of a list. Okay, so first of all, again, we separated the outputs visually, and our goal now is to remove the outliers from our sorted list. And in this case, the outliers in our situation is going to be the smallest and the biggest. And since our list is already sorted, that means that the outliers, or the biggest and the smallest, are going to be the first and the last numbers inside of this list, or items inside of this list. So the index before the colon 1, this is the colon, the index 1 is going to be the first number. So we slice this sorted numbers from the first one. So we remove the first element and we start at, if you want to call it, the second one. But remember, when we're working with a list, we always have, or we always start at index number 0. So we start from 1, which means we remove the first element, and then we go all the way until -1. And when we say -1, it means that we are slicing from the end. So in Python, negative indices count backwards from the end of a list. So -1 is going to be the last element. And also keep in mind that when we're slicing, the end is not included. So basically we're going from the second element at index number 1 to the last, or how do you say it, before the last one. So at -1. So now when I right click and I run, I'm going to enter 95146 0. Boom, as you can see, 987654321. I guess that's everything. And as you can see right here, I have removed from the sorted list, keep in mind I'm working on the sorted list, I've removed the 1 and the 9, so the outliers are gone. Okay, so my favorite Python programmers, congratulations on making it throughout this program. Again, something I want you to remember is that you might have written this code completely different than mine, and that's completely okay as long as everything in it works. But if you haven't used your own knowledge to create this program and you just followed along with my video, now is the time to challenge yourself, because I'm going to give you a challenge. So let's go ahead and look at that challenge. Okay, so it's time for some data analysis. I want you to create a function that does the following. First of all, it takes in a list of numbers and prints out how many numbers there are. Next, you need to calculate the average of these numbers. And by the way, these numbers are going to be somewhere in the description. I think it's around like, it's a huge number of numbers. So I'll probably leave it in a file that you can download. Don't worry, no viruses. It's just a simple text document. Calculate the average of these numbers. How many numbers are over the average and how many are under the average. Calculate the variance, and this is a formula that you'll need to find. And I know this is probably something advanced, but I'm trying to give you more knowledge every time that we get to a new video. So data analysis will have a lot of variance, which will require you to go and do some research, find the variance, and then convert that formula into Python code. And this is going to be a very fun challenge. If you don't know how to complete this, don't worry, you can always complete the first 3, watch how I did this one, and then go back and try to continue on. The next thing is to calculate the standard deviation, which is going to be the square root of the variance. And again, there are several ways to get the square root of your variance. Filter out all the negative numbers. So what is the average of these negative numbers? Just create a new list where you have all the negative numbers only. calculate the average of that, filter out all the positive numbers and what is the average of that. Next, I want you to normalize the data using the equation of normalization. So again, go research how to normalize something or normalize a list or whatever, normalize numbers in a list, and then actually apply that equation and get the average of the normalized data. And if you know anything about normalizing data, you should know what that value is going to be. So pause the video right now and go do the challenge. Okay, so as you can see in here, I made a huge mistake. Boom, there we go. Now we are good. First of all, what I did is I minimized this entire main method. I didn't want to really delete it, or actually maybe we can comment these both out. Boom, as you can see, lower it down. And the way I commented this out is by selecting everything and doing Ctrl//, and I don't want to remove it, I just want to keep it. I also recommend that you don't. So first we define the new function called analyze and transform that takes in one parameter, that is the numbers. Inside the function, the first thing that we do is we actually check if the list is empty or not, because we're going to be working a lot on this list, so we need to make sure that it's not empty. It actually has some values in it. And by the way, you didn't have to do this. I just want to show you the best way to actually program, and this is a fairly important step to do. And the way we check if this numbers list is not empty is using the if not numbers. So basically in Python, an empty list is considered a false in a Boolean context. Booleans, you have true and false, but if you want to check for a list if it's empty, an empty list gives you a false. A 0 in an integer context also gives you a false. So in this case, if the numbers right here is empty, that means this is false. That means not false is equal to a true, which means if true, we go in here, we say that a list is empty, and we return, and this effectively breaks out of our entire method. And this is important because, again, if there are no numbers to analyze or transform, the function should not do anything else to avoid errors. Okay, so in here we use the built-in length function, or len with parentheses right here, to get this count, or the count of numbers inside of our numbers list, and this returns the number of items inside of our list. And we are also using the f string right here to print out the values. Something to keep in mind, as you are typing len, you're going to get suggestions whenever you open up these squiggly brackets and you start typing something inside. You'll get suggestions, you hit tab, and the f is added automatically at the start. But I do recommend that you add the f manually, because sometimes you might be in an environment where the autocomplete does not work like that. Now I'm going to go ahead and test this function out, and for this I have a massive list that, as again I told you, is going to be available to you. I'm going to copy it right here from the side, and it's a massive list. Boom, there we go. So look at all these random numbers that I generated using something called the NumPy. Something that is fairly advanced for you now. Let's just focus on actually having or using these numbers. And in here, I'm simply going to let's go ahead and analyze and transform. And I'm going to send in these numbers and just hit enter right here just to separate. And now when I right click and I run, let's see. So the total number of numbers, or the total numbers, are 1,847. How cool is that? So in here, I want to just show you. So for example, if I type in average, 2 dots, open these parentheses up and type in average, you can see I get the suggestion. And notice how a small f will be added at the start. So I hit tab to autocomplete, and this small f is added at the start. So in here, we are calculating the average. First, we use the sum function, which returns the total sum of items in a list. Let me hover over it, see if I get any. Okay, so returns the sum of the start value plus the iterable of numbers. When iterating is evil, return empty, I mean. Okay, so doesn't explain it well in here. Basically, what it does is you give it a list and it sums everything up and gives you that number. Then after we have this, to calculate the average, we need to divide it by the total number or the total sum of the numbers. And in here, I just use the length again to get the total amount and then printed out the average. Let's right click and run. And as you can see, the average is actually 13.45. And the reason for that is because we have a lot of negative numbers. That's why I created this list with a bit of negative and positive numbers so that we have something in between. So 13 is the average, or 13.4585. And by the way, if you don't want to see all of these numbers and you'd like to just have two, what you can do is after the average or after any number that you're trying to print out, you add 0.2 and then F. And now when I right click and I run, you can see that only two numbers were printed out. If you want 3, you change this to 3. Boom, as you can see, now we have 3. This is a very nifty trick that you can use, and I kind of like it like that. Very simple, I don't want to have that much precision. Okay, so now it's time to calculate the numbers that are over the average and the amount of numbers that are under the average. So first of all, we initialize the two counters that are the over and the under to both be 0. These will count the numbers that are above and below the average respectively. Should be pretty obvious. We then iterate through each number in our list using the for loop. Again, we set every individual item that we iterate over into num, and then inside of the for loop we check if this number is greater than the average. If it is, then we increase the over by 1 using the plus equals 1. This increases the over by 1. And I've already explained the plus equals so many times in previous videos, so it should be pretty obvious. We're incrementing the over. Otherwise, we are incrementing the under, and finally, we are printing them out. So if I right click and I run, as you can see, we have 937 numbers above the average and 910 below the average. But this is a good way to write it. Or actually, let's say it's not an incorrect way of writing it, but there is a better way, and I'm going to show it to you now. Okay, so look at this scary expression. First of all, let's test out and make sure that it's still correct. Yes, we are still getting the same output, 937 above and whatever under. So what is this? So first of all, let's break down this expression right here, and then the second one should be pretty obvious. First, I would ask you to pause the video and try to figure out what's happening on your own and then hear the explanation. So 3, 2, 1. For the over, the expression or the expression that you see right here creates a sequence of ones for every number in numbers that is greater than average. This is what this expression does without the sum. Again, this creates a sequence of ones for every number in numbers that is greater than the average. And this entire expression is called a generator expression. This particular expression iterates over each number in the numbers list, and then for each one of them, it stores it in the num variable, and then checks if this num variable is greater than the average, it makes a 1. If it's not greater than the average, it does not make a 1. So effectively what we're doing is creating a sequence of ones that represents each number over the average, and then finally we use the sum function to add up all these ones, which then turns into a turns into the number of numbers that are over the average. This is not something simple. I personally rarely use such expressions because it can be confusing, even for me, even for a seasoned programmer. I sometimes look like, oh, wait, what's that? For me, this is much better, but you're going to encounter this a lot when you're out in the wilds and looking for different expressions and ways to create programs. So I wanted to show you how generator expressions work because we're going to be using them later on with something that's slightly more complicated. Now let's go ahead and set the variance. Okay, so as you can see right here, this is the equation for the variance. I just typed in variance formula and this is what I got. Now, it might seem a bit complicated, but when you break it down, it's pretty simple. This is the sample variance, so this is basically the variance, what just happened here, okay, don't care. And right here we have the sum, so this is the sum of everything. We have xi, this is the value of the one observation, so every single item that we are going through in our list. So this is each individual item. We subtract from this item the average, which is the mean value of all the observations, and then we divide it by the number of observations that we actually have. But before we do that, notice right here, we take it to the power 2, we sum everything up, and then we divide it by the number of observation. So how do we convert this right here? So I'm actually going to try and set this like this, so we can actually look at it and the way we've converted. Okay, so right here, first of all, we start off with the summed being 0 because we want to initialize the value of all the sums. Next, we start with the for loop, and inside of the for loop, we calculate the difference between the current number. So we are going through each number. Oops. So we're going through each number. So we I'm not going to press on the screen anymore. So inside of the loop, we calculate the difference between the current number num and the average of the numbers, which is going to be the average that we've calculated before. This difference tells us how far away each number is from the mean or the average. We then square this difference using the two multiplication symbols and 2, which means we are squaring it to the power of 2. We then append it, or we we increment the summed by the number, so we can see right here, and it's exactly as the formula right here suggests. So xi minus the average, which is x with a dash above it, and then we take it to the power of 2, and then we sum it all up, and then finally the variance will be equal to this sum number divided by the length of numbers. So let's go ahead and look at the variance. If I right click and I run, boom, you can see that the variance is this huge number. And by the way, I don't expect you to fully understand or to fully comprehend what this variance means. I will tell you more about what the standard deviation is because it makes a bit more sense. And I'm just going to add a 0.2 just so we can have a better looking number. But this is a bit excessive. I'm going to show you how we can do this using a generator expression, as if this was not complicated enough. Okay, so this is the generator expression again that iterates over the numbers list, and for each number what it does is it gets the num minus average to the power 2 and then finally sums everything up and then divides it by the length. Take a bit of time, try to understand it. Again, it's not necessary. I kept the initial one just so you can see it for yourself and then try to convert it into the second variance. Actually, let me move this by holding down Shift Alt and using the arrow keys, and boom, there we go. So I'm going to separate these two variances and you can look at them and you can choose which one is more comfortable. I personally like the first one. It's much more convenient to me, but as you can see with this second one, with the generative expression, first of all, it looks a lot better. If somebody sees you writing this generative expression, they'll be like, all right, man, we're hiring you, you're amazing, that's it, you got the job. But no, actually, when somebody sees you use generative expression, they will think of you as a more advanced and more seasoned programmer, but it's a bit confusing. So take your time, try to properly understand it. Once you get it, it's fairly easy. Nothing is complicated. It's the same exact thing. We're just using a single line to do it, and we're shuffling things a bit around, but the logic is still there. Okay, so now we're calculating the standard deviation, and as I told you, the standard deviation is just the square root of the variance, and to calculate the square root, remember it's as if we're doing to the power of 0.5. So now when I right click and I run, I forgot to show you both variance. So as you can see, variance 1 and variance 2 are exactly the same, and we have the standard deviation. So what is the standard deviation? I'm not going to delve too deep into it, but all that you need to know about the standard deviation is, if you want to think of it, it's the average amount that any given number deviates from the average. So for example, let's say we take any random number in these numbers. Let's say it's 4,530. The average is 13.44. So there is, let's say, I don't know, some 4,500, okay? That's more than 2,800. But if you take a number like minus 92, it deviates about 100 from the standard. So from the average. So if you take all of these deviations of all of the numbers, on average, they will deviate by 2,892.0.3. And variance and standard deviations are crucial parts of statistical and data analysis, something that you'll learn as you get more advanced. So this is a great way to just give you an overview of this. Now, we used this equation to get the standard deviation, but there is a slightly better way, and that is through importing the math module, and then I'm going to make a standard deviation 2, which is going to take the square root, so math.sqrt of our variance, and I will duplicate this again, and to duplicate you just hit Ctrl D, standard deviation 2 and stddev 2, and then when I right click and I run, as you can see, we get the same standard deviation. Basically, we use a method inside of the math module, that is the sqrt, square root. It works exactly the same. Okay, so now we are filtering out all the negative numbers into positive numbers and getting the average. But we're doing it in some fancy and crazy way that you might have not seen before. This is called the list comprehension. So basically this line of code right here uses a list comprehension to create a new list called the positive numbers, filled with only positive numbers. This is achieved by, first of all, iterating throughout, and if you notice, it's very similar to generative expressions, but it's slightly different. Why? Because we're using these square brackets, which actually turns this expression into a list at the end. So first of all, again, just like we've done before, we go through each number in the numbers and we set it into num, and then we check if num is greater than 0, we finally make it into a number. Remember, in here I told you that we are making a sequence, but then when we add the two square brackets around them, around this sequence, because look, it's basically exactly the same as the generative expression. When we add the square brackets, it becomes list comprehension, and we can just create a list fairly quickly. So when I right click and I run, you can see that the average of non-negative numbers, and again, let me add the 0.2f just to make it look more presentable. The average of positive numbers is 2,483. Very nice. Okay, so basically for the negative numbers, it's exactly the same. I even copied it and pasted it. So when I right click and I run, as you can see, this is the average of the negative numbers. We also used list comprehension to do this. Okay, so now it's time for data normalization, and basically what I did is I typed in normalization formula or normalizing data formula or whatever. You would have found this formula right here. Now this one looks scary as hell, this one looks more digestible. So I'm going to click on that. And as you can see, basically each normalized value, which is x new, is going to be equal to the value x minus the minimum divided by the max value minus the minimum as well. So again, I'm going to make it like this so we can see what we cooked up in here. I'm going to move it a little bit up and scroll. Okay, this is not looking good. Wait, let me try. Okay, looks ugly as hell. Just let's try to do it like this. Okay, seems to be working good. So first of all, what is data normalization? Basically what we do whenever we have a wide range of data, as you saw, we have -19, 4000, whatever, we have data all over the place. So the data normalization is the process of organizing this data to minimize and improve this data's integrity, or minimize redundancy, meaning that we have data that's not very useful and all over the place. We just improve its integrity. We make sure that it's all on the same playing field, and it's used to enhance the efficiency and clarity of your data structure, making it easier to manage, easier to analyze, and reduces any data that is a bit of an outlier. Like maybe all of your data is between 1 and 20, and then suddenly you have a data point that's 40,000. Not good. So with normalization, we actually reduce this 40,000 to something that's manageable for these 1 through 20. In this case, we would get rid of it, but it's just a very important concept that a lot of data analysts use. So how did we do this? First of all, we got the minimum number, which is the smallest number, using the min function. We then used the max function to get the biggest number. Then we used a list comprehension. So as you can see, we've already seen this. We add these two brackets on the side. We go through each number in the numbers, and then we simply use this number. As you can see right here, this is the number, this is x minus min num, which is x min, and then we divide it by x max, which is max num, minus min num, and then finally we print it out, and we also got the average of the normalized data. So I hope that's understandable. Please take your time, go through this. This is not easy. You're learning new formulas, you're learning new concepts in Python, but all of these things are crucial. I cannot emphasize it enough to build up your programming Python arsenal. So let's go ahead and right click and run. And as you can see right here, we have a very ugly number, which I'm going to make better with the 0.2f, which did not work for some reason. What do I have in here? Normalized, unsupported format string passed. Okay, so I just realized that the normalized data is not an integer, and instead it's a list of all of these numbers. So notice that now everything is between 0 and 1, and as you can see, everything is 0.9495, 0.06. Everything is below 1. Look, 0. Like, you can go through all of these and you can see that all of them are between 0 and 1. And this is what I mean by normalizing data. Everything becomes almost the same. And what's the average of that? 0.5. The average of normalized data is always going to be 0.5. Okay, fellow Python programmers, that was a big exercise. I mean, we've learned and we've done and we've gone through so much. If you enjoyed the content, leave a like, subscribe, whatever, because we are going to be continuing on our Python programming journey with this exercise right here. So to continue your Python programming journey, click on this video right here. Let me move the mic a little bit more. Right here, as you can see, yes, I can see it clearly on the camera. I will move a little bit to the right so you can also see my beautiful face, and continue on your Python programming journey. Let's go.